Now, just to make sure that you're okay with these three questions, I'm going to put the solutions here. Work through them, you can check your answers, and once you've checked these three solutions, then you can go off and do the worksheet, and we'll have a live class tomorrow to take care of that worksheet. So potassium hydroxide and sulfuric acid react according to the following equation. Now, why do they give us a balanced equation? They give us a balanced equation to get what we call the ratio of reaction. See that? And in this case, because it's not 1:1, we've got to remember to take those coefficients into consideration. What volume, V1, of 0.2 molar KOH, M1, is needed to react completely with, there's my second volume, of 0.245, that's my second molarity. Okay, and in this case, I'm reacting 2 KOH with H2SO4. Now, what I normally do is I always write down the volume, the molarity, the volume, and the molarity, because they're going to give me the number of moles of each. So the volume and the molarity of KOH is, the volume is X, because it's asked me what volume. So the volume is X, and the molarity is 0.2. Over here, the volume of H2SO4 is 15.2 centimeters. Now that's 0.0152 liters. So don't be afraid to use liters. And then the molarity, the M2 over here, is 0.245. Now, we've got to remember that we can multiply out these two. So we get 0.2x equals 0.245 times 0.0152. But we've got to take into consideration the ratio of reaction, 2:1. So we have to bring in, divide that by 2, and divide that by 1. So in other words, work out your number of moles, and then apply the coefficients of the ratio of reaction as divisors or denominators to the respective sides. So what's that going to give me? That's going to give me 0.1x is equal to, get your trusty calculator, so work out, well, 0.2 divided by 2 is 0.1, and then we have 0.245 multiplied by 0.0152, and that comes out as something very, very small, 0.00372. That's plenty. Meaning, when we divide across now by 0.1, x is equal to, so divide that by 0.1, and you end up getting 0.0372. Okay, now that's what? That is the volume of the KOH. So if you wish, that's always going to be in litres. If you wish, turn it into centimetres cubed by multiplying it by 1,000, and you end up with 37.2 centimetres cubed. That's the answer. Okay, so that's the volume of 0.2 molar KOH needed to react completely with 15.2 centimeters cubed of 0.245 molar H2SO4. I hope that's okay. Next one. What volume? So again, my V1 is going to be X. What volume of a 0.283 molar HCl solution, so that's my first molarity mentioned, is needed to neutralize 259, that's my second volume, of a 0.0431 molar BaOH2 solution. So that's my second molarity. Now again, they give the reaction. And the reaction is important because it sets out the ratio between the two substances, which is 2:1. Meaning that when we use our V1M1 equals V2M2, we have to divide both sides by the respective numbers, 2 and 1. So you can fill out the formula if you wish, very, very easily. What's that going to give me? Well, V1 and M1, what are they? V1 is what volume? So V1 is going to be X. So X times the first molarity, 283, over 2, is equal to the second volume, now in litres, 0.259 litres, multiplied by the molarity, 0.0431, all over 1. And in a situation like this, again, you can get X on its own by taking 2 from the bottom left to the top right. So this is one quick way to do it. Take the 2 from there, put it up in the top right. Take the 0.283 from the top left and put it down here, 0.283. So basically what you do is you cross over the numbers that you don't want with the X. So the 0.283 gets crossed over to the bottom, the 2 gets crossed over to the top, and that is going to be your answer of X. So turn on your calculator's fraction function, 2.259 in brackets, and 0.0431 in brackets. And that's over 0.283. And if your calculator is of any use whatsoever, it's going to tell you that the answer you're looking for is 0.07, now 888, so 0.0789 if you want to do it that way. Okay, what? Well, what volume? So it's litres. And again, if you want to give it back in centimetres cubed, or you're told to give it back in centimetres cubed, multiply by 1,000. What's that? That will give me 78.9 centimetres cubed. And that's the volume of that solution. Okay, so as long as you've got the balanced equation, really, you know what to divide your V1M1 and your V2M2 by, and that's important. Okay, the last one. Again, calculate the volume. I should have given you something different. Now looking at that anyway. V1 of a 1.420 molar, that's my first molarity, required to titrate 33.55. So that's my second volume mentioned, and 1.5 molar phosphoric acid, that is my second molarity. Now, let's check the ratio of reaction from the balanced equation. 1 is to 3. So my V1M1 over here is going to be divided by 1. And my V2M2 over here is going to be divided by 3. Okay, now we've got to be careful that we keep these things under one another. So we're dealing with the phosphoric acid over here. The phosphoric acid, where is it, is 33.55 millilitres of a 1.5 molar phosphoric acid. So there's everything you need about phosphoric acid. So put it under here. What's the volume of phosphoric acid? 33.55 millilitres, 0.0335 litres, multiplied by the molarity of H3PO4, 1.5, all over 1, is equal to NaOH. Well, what is the volume of NaOH? That's what we're looking for. Times the molarity of NaOH, 1.42, all over 3. And again, we do the same thing as before. Take the 3 from the bottom right to the top left, and take the 1.42 from the top right down to the bottom left. And that's going to give you X being equal, and again, trusty fraction function. Okay, so you end up with 3 bracket 0.03355 by 1.5 over 1.42. And the answer there comes out as 0.106 litres, because it's volume they're asked for. Now again, what will that be? That's 106 centimetres cubed. So it's very important that, again, ratio of reaction, you then keep the values that belong to phosphoric acid under phosphoric acid, you keep the values that belong to NaOH under NaOH, and you simply apply the ratio of reaction. Now, if you're okay with those and you've managed to do those, well done. Off you go with the revision sheet now, and we'll come back and look at the revision sheet in the live class tomorrow.